Let's add the boilerplate code to wire up our new module. First, I'm going to close all these, and we're going to start with adding some files to the types directory. The types is always containing stateless types and validations. When, for example, if you remember, I talked about during the check transaction, there are stateless checks. All those stateless checks would be included in the types. So we can start with a new file inside types called keys.go, and let's go to the example to see what goes in these files. So you will see that they have this keys.go in the root folder. Most of these files that you will see in the root folder of this example, I'm going to place them inside the types. So in this keys.go, we're going to define the module name and the keys for the store of the module. So this is the package types, and our module is going to be called RPS. At the collections, we get the import from the Cosmos SDK collections to create our keys prefix. In our case, we're going to start with the simplest setup when we are going to only add the params keys, but later on we will add here our games keys to store games. The next file that we need to add is the codec. Here we have an example, codec.go. In here we will register all the interfaces of the module inside the interface registry. If we don't register the different messages, for example, we will not be able for users to submit this type of messages. So let's copy this code and create our codec.go for a module. This is going to be package types. And for now, because we are not yet implementing the message server, we will remove this for now. We'll comment it out. This message we don't have it. And if you're asking how this gets this type message update params, well, this one is generated from the protobuf that we did previously. So you see inside our types, we have the transaction.pv.go, and we have already all the messages defined here. The message update params, and we also should have the message create game and make move. We have already all this generated. Message create game. So for now, let's leave this empty. The next file that we should get is the genesis.go. This is going to create a new Genesis state. Mostly this is used when you're starting a chain. You set a default Genesis, and the application will call this function to get what's the default Genesis state for that module. So let's get all this code and create our genesis.go in our package types, and we're going to remove all the counter logic that's not relevant for us, and we will have to define these default params. Again, the Genesis state is defined in our Genesis protobuf that we previously wrote. We define it to have the params and the games. If you remember, in the Genesis proto, we defined this, and our scripts generated this Go file. Let's add the params here that we will need it. Params.go, and let's go to the example to have a reference. we have here params scope, and it's just these package types. And there we have our params. For now, we don't have any params, so this is empty. And our validate, it's not doing anything yet, our validation function. This is again a stateless validation because it's within the types directory. And now we have our genesis with our default params and the validation, calling the validation. When we will add here the games one, we'll have to add also some validation in here for the game. For now, and we can continue now with the keeper. Here is the meat and potatoes of the module where the business specific logic and state transition and queries functions will be defined. And we will have a keeper struct here, then it would be our module's keeper. Let's go to the example, and you will have this under the keeper directory. If we go to keeper.go, we can get all this code. Obviously, we are going to remove some of this, but it's a good starting point. This is going to be, we're going to remove this, the params. We're going to keep only the params, and in here we're going to import our types because our params are defined in types. Here you see we have our import from our package, and we remove here the counter. We only keep the params. We get the keys from the types. Same here, types. This is a function to initialize a keeper, and we'll check first the authority. Usually this authority is the governance module address, and then it will create a keeper instance, build the schema. This builds the schema with these new collections, and this is used for interacting with the store. In this case, we are just having the params, and then it's returning the generated keeper. And then we'll have a getter function to get the authority of the module. Can be used for querying which is the authority at the moment. As we saw previously in the slides, as you can see, a keeper has the binary codec required for serialization and deserialization of messages, an address codec for the addresses, and this will be related to our prefixes that we defined in our config. If you remember these prefixes, and then the authority that is capable of executing the message update params to update the params of the module via governance, and then this is state management, this schema needed for managing the collections, and the collections itself, in this case just a params item that contains at this moment nothing, but we will extend this later. The next file that we need to add here in the keeper, it's a genesis.go file, and this will be in charge of setting the genesis of the module. Let's go to the example and look into the genesis.go. It's going to be a very simple file. You see we have this init genesis, that it's initialized the module state from a genesis state, and then we have a function to export the current module state to a genesis state. When you call this function, you will export the application, well, in this case just the module state, and it will be dumped into a JSON file. We'll look into this later. So let's get these functions. And keep only the params. In our case, just the Genesis state. We're going to only set our params that are going to be empty, and also the same for the export Genesis. We'll get the current params and we'll return a Genesis state with the current params. And here we'll have to import our types. Same here, types. Let's format. And that's it for keeper for now. And then we'll have to define some other key files. The first one is called module.go, module, and this is where we define our module version, and we define and comply with the application module interface to be ordered to be managed by the module manager. So let's look into this. In this example, we have this inside the module directory. I will see the module.go. As you can see here, it has an app module basic that it has to comply with, an app module, and this also this interface to signal that it has a Genesis that should be called on Genesis. And this is just complying with this interface that allows, for example, for registering the codecs and the gRPC gateway routes, the interfaces of the module, the consensus version, the gRPC services, message and query services, the default Genesis, validate Genesis, init Genesis, and export. This is mostly calling keeper methods, so straightforward. Let's get all this code and use it in our module. So for us, the package is going to be package RPS, and we're going to use all these, but we'll have to change some things. First, this one, we're not going to use those. The keeper is going to be our keeper. github.com xab RPS chain x RPS keeper. That's going to be our keeper. Now it's not complaining, it's having our keeper. This is our app module that you can see here. We define our app module to have a codec and a keeper, and this app module has to comply with app module basic that has these three interfaces, these three methods that we have to comply to register interface and gateway routes. It has Genesis, specifying that this module has an init Genesis and export Genesis, and the app module has a dummy method to specify if it is an app module. Here let's add our types. We're using our types now, same where it says example. For now, we're actually not registering any gRPC and services here, so for now I'm just going to change these imports, but you see like the keeper method to get the message and query server implementations are not yet defined. So for now we will comment this out. We're not going to register any service for this module. The interfaces is, as we saw previously, this is just an empty one that we commented out for the moment. And the same with this. Let's just comment this out for the moment. We're not going to use that. And let's see what else. The Genesis state, default Genesis, the types. Here we have to change types to validate the Genesis, and this will initialize our Genesis as well. Let's change this to our types to get our module name correctly. And that's it for that. I'm getting some alerts here. Let's see. Context. So in here we did all the changes that we need. We're getting this alert. Then we are not having this ISAP module method defined, but that's okay. That will be included in another file. So let's continue. The other files that we need to add are here inside the module, the dep inject, that this allows for dependency injection of the module to wire up this module using this dependency injection method. So here you see that we have defined this ISAP module, this one per module type methods, and we will register here the module, that this is the using the protobuf that we defined, and defining the different module inputs to provide a module via dependency injection. So let's get this code and get it into our module, make the corresponding changes. So we're going to add another file in the RPS directory. That's going to be dep-inject.go, and this is going to be package RPS. That's our module, and we're going to add this. And let's see what we have here. So the module one, this is going to be our module, github.com 0xlb RPS chain, and it's going to pick it up in this case from the API module v1, that it's API RPS in our case, RPS. So it's picking up the RPS module. Is this one. This was generated from the module.proto that we define here. The authority is picking up this from the generated file. The next one is the keeper. In this case, it's the keeper of the module. Let's fix this import to the X RPS keeper. And let's see if everything here is okay. This one is defined. We're going to use this same model inputs. This is kind of standard, pretty much the same for every module. Here we define the default authority. As you can see, is the governance module address, but you can define it to be whatever you want. And yeah, that's it for the dep inject. And there's one more file that we should add, that it's the auto CLI that will be used to wire up our CLI commands for this module. Auto CLI.go. And let's see the example, what we have here. In this case, they already have some commands defined, so that's why they're having this. But for now, we will just use the params, and this is going to be package RPS. And this is going to be our LP RPS chain API RPS v1. Let's rename this to RPS v1. That's our module name. Rename RPS v1. There you go. So you see it's keeping this RPS v1. And the counter is not a method that we have in our chain, so we'll remove this. We can leave these params for the moment. Increment. This is not going to be used. For now, we'll leave this as nil because we are not having anything implemented at the moment for this. But yeah, here is where we are going to come later and wire up our queries and transactions. There we go. We remove the unnecessary import. That's it. Well, we have pretty much all the boilerplate code needed. Now we have to wire it up in our app. Let's first create a branch with these changes so we can have it as reference. We're going to create a lesson 2 branch and we are going to submit a commit with just the boilerplate code, and then we're going to wire it up with the app and add a commit with that. So git checkout branch lesson 2, git add all that we just added, git commit message add boil code for RPS module X RPS module. See if we have any problems, not just warnings. Git push origin lesson 2. Now let's wire this with our app. Wiring up our module is straightforward, and wiring up actually any other module that it's compliant with the app module interface. So let's look into this. We're going to open the app.go, and here we're going to add our keeper. Here is going to be our RPS rock paper and scissors keeper, and we had to import our RPS keeper type. That we should add it here. RPS keeper is going to be github.com/0xlb RPS chain, and our module RPS keeper. Now we have our keeper here. Let's format this, and we have to add it to our config in YAML. In app.yaml, you will see here we have all the modules. We're using this dependency injection using the YAML, so we should add it here. It's pretty much copying this and changing here name RPS, and in our case this is going to be LB RPS module v1 module. This is going to pick up this module.proto. You see it's the same package name, LB RPS module v1 module. It's going to pick up this. That's why we need this module.proto when doing dependency injection. And then we'll have to add it here to inject it to our app RPSC RPS keeper. And then everything is set up. The module manager will take care of it, and dependency injection as well. So let's see how now it's working. So to check if everything is working okay, we can install the application RPS chain, make it install, Make sure that we can compile the binary successfully. Everything went okay. Let's check the version. Oh, there seems to be some problem with the wire app, that the module was not found. Let's see what's going on here. You will notice that the error message that we are having is related to the protobuf, and that we cannot resolve this LB-RPS module v1 module that we are including in our app YALM here. But if you look in the app.go, you will see in these imports that we are importing this for side effects, and this what actually is doing is registering this interface. In our case, if we go to our module, we have our dev inject file, and here you will find this init function. So because we are not importing this RPS package anywhere in our app, it's not running this init function that registers the corresponding proto. So let's do that. So here we will add the corresponding import to bring the protos for this module. The same here is used for these other modules. And we format that, and let's try again to compile it. And now run a command and see what's happening. Now we are having the binary working correctly. We can try starting a chain. We will do making it. You can see that in here our genesis now includes the RPS genesis. That's going to be the empty params and the games. So this makes sure that you have this to ensure that you have wired properly the custom module. And now we can start the chain. Obviously start, and we're having another error. Let's check now what's happening here. Okay, so we're missing a set order genesis. This is also expected because we define in our module that we have a genesis and a need genesis. So we have to specify to the module manager what's the order to run these genesis functions. And this it's done in the app.yalm. In this case, you will see that in here we're going to set the order for different functions. For example, the begin blockers, the end blockers, and the need genesis. In our case, we can add here our module. It doesn't matter what order it is because it's not dependent on any other module's genesis. And now let's try again to compile it. And let's init. And let's start RPS, start, this thing start. And now you can see that we have everything wired up properly, and the chain has started. And if we check in our genesis, you will see that we have our modules genesis. This is RPSD config. Let's open the genesis, and you will find here, let's look for RPS, and here we have our genesis for our module. Right now we are not having anything here, but when we start to add messages to add games, we can use the RPSD export command that will go to it's going to export the current state to a JSON file, that we're going to place in the temp folder. I have to stop the node to do this. Now we can export, and we look into the exported state. You will see. Let's configure with prettier. This is the current state, and you see we have here RPS. For your reference, I already uploaded the changes in one commit to wire up our module. That's already in the lesson 2 branch. And also I updated the README with what we covered in these last few changes.